All right, here we're going to review a bit the Pythagorean Theorem. Now, the Pythagorean Theorem is for all right triangles. You must have a right triangle to use the Pythagorean Theorem, and it says a squared plus b squared equals c squared, where a and b are the legs. Okay, so a and b, sometimes I like to say leg squared plus leg squared, and c is always the hypotenuse. That's that longest side that's across from the right angle. And the reason I like to say it this way sometimes is occasionally students will get mixed up and think you can put any number in for A, B, or C, and that will cause problems. So know that A and B are the legs, and that C is the hypotenuse. And again, hypotenuse is that longest side of the right triangle. It's always the one across from the right angle. So here's an example. If we wanted to find the measure of x, we have a right triangle. Now notice these are lengths of sides and they are not angles. So the length of this side is x, length here is 8, and the length of this hypotenuse is 10. We have two of the three sides, so we can use the Pythagorean theorem to solve this. We want to set it up carefully. Leg squared, one of our legs is x, plus leg squared, the other leg is 8, equals the hypotenuse squared. The hypotenuse was 10. We go ahead and do your squaring. 8 squared, 8 times 8 is 64. 100, or 10 squared, 10 times 10 is 100. Next, we want to isolate the x squared, so we're going to subtract 64 from both sides. I'm left with x squared equals 36. To get rid of a squared, the opposite or the inverse of that is doing the square root. So I take the square root of both sides, and usually I tell you that when you do a square root to solve, you put a plus or minus. But since this is the length of a side, and lengths of sides can't be negative, lengths can't be negative, we're just writing positive 6 as our answer. Okay, so that is one way you can use the Pythagorean theorem. Another thing that comes in handy with the Pythagorean theorem is that you can tell right away, given three lengths, whether they would be the lengths of the sides of a right triangle. And how do you do that? Well, if they work in the Pythagorean theorem, then they could be the sides of a right triangle. How do you know what's A, what's B, and what's C? Well, the hypotenuse is always supposed to be the longest side, so whichever one is the largest number, that's your C. The other two are A and B. It doesn't matter which is A and which is B. So what you do is you test them. Okay? You test them in the Pythagorean theorem and see if they make the equation true. If this is A, B, and C, is 3 squared is 9, 2 squared is 4, and 5 squared is 25. Does 9 plus 4 equal 25? No, it does not. So we could definitely say that these are not the sides of a right triangle. They're actually not the sides of any triangle now that I look at them. But again, what you're doing is taking the Pythagorean theorem, make sure A and B are the two smaller numbers and C should be the biggest number, and you're checking to see if it makes that true. Okay, so for this one, our two smallers are 5 and 12, and the largest is 13. So this is going to be our C. The other two will be our A and our B. So we have A squared plus B squared equals C squared, and we want to see if that's true. 5 squared, 5 times 5 is 25. 12 squared, 12 times 12 is 144. And 13 squared, 13 times 13 is 169. Does 25 plus 144 equal 169? It actually does. So this would be the sides of a right triangle. So this one's a yes, this one's a no. So that's how you can test that. Let's do some application problems using the Pythagorean theorem. So here we have a jogger. Goes 4 miles due south, 3 miles due east. What is the straight distance between the starting and the ending point? Well, let's give her a start point, or him. And we're going to go due south. So we're going to go straight down for 4 miles. Then we are going to turn and go to the east. So we turn right here for 3 miles. And we stop. Okay, So there's the starting point and the ending point. They want to know what is this distance, the straight distance if they had not gone south and east, just diagonally across from start to end. What would that distance be? Right, well, notice we formed a right triangle here in our situation, so we can use the Pythagorean theorem. A squared plus b squared equals c squared. We have the legs, A and B. We do not know our hypotenuse here. Remember, it's that long side across from the right angle. That's how you spot it. Put in our information. So our A and our B, our legs are 4 and 3. Our C, we're not sure. 4 squared is 16. 3 squared, 3 times 3 is 9. Add 16 and 9 gives you 25. And finally, we take the square root. Again, we're not going to use -5. Normally would put plus or minus, but -5 can't be a distance. So 5 is the only thing that makes sense in this situation. All right, here's another application. One end of a rope is attached to the top of a pole 60 feet high. If the rope is 110 feet long, what's the maximum distance along the ground from the base of the pole to where the other end can be attached? Assume the pole is perpendicular to the ground. So we've got a pole of some sort, maybe a flagpole or something, okay? And it is 60 feet high. It's perpendicular to the ground, so it makes a right angle with the ground. We have this rope that's attached to the top of the pole, and we want to stretch it out as far as we can and attach it to the ground. So we stretch it out, and how long is that rope? The rope, it said, was 110 feet. Okay? We want to know what is the distance along the ground here from the pole to the place where the rope would be attached. Again, notice we have a right triangle and we have 2 of the 3 sides of that right triangle. So we would use our Pythagorean theorem to solve this. A squared plus b squared equals c squared. This time our legs are 60 and x. Our hypotenuse, we know it's 110. Okay, 60 squared, 60 times 60 is 3,600. Plus x squared equals 110 squared, which is 12,100. We would subtract the 3,600 from both sides. That gives us 8,500 left, and now we just take the square root of both sides. When we do that, we get that x is about 92.2 feet. All our dimensions were in feet, so our answer would also be in feet. Okay, one more example. Susie's kite is tangled in the top of a tree. The kite string is 40 feet long, and Susie is standing 24 feet from the tree holding the string. How tall is the tree? All right, well, so we've got a tree here. Susie has got her kite stuck in the top of that tree, and she's standing on the ground holding that kite string. Okay, well, the tree, we're assuming, is perpendicular to the ground in this question. Okay, what things do we know? We know the length of the kite string. So here's our kite string going over to Susie. It's 40 feet long. She's standing 24 feet from the tree. So this is our distance along the ground here. She's 24 feet away from the tree. We want to know the height of the tree here. Again, we have a right triangle, so we're going to use our Pythagorean theorem, that a squared plus b squared equals c squared. We know our legs, one of them is x, the other is 24. The hypotenuse, the side across from the right angle, is a length of 40. Okay, we go ahead and do our squaring. 24 squared is 576. 40 squared is 1,600. And we solve from there. So I would subtract 576 from both sides. That leaves me with 1,024, and finally take the square root. Get rid of that square. Don't forget that step. It's a common step that's forgotten. When I do, I get 32. So the tree is 32 feet tall.